Hello everyone, this is Greg and this is our EDDC 608 February 21 week 7 8 transition video. I hope you're all doing well. We had our official half day off of school in Oregon today. Winter lasts exactly half a day in this state. And those of you from Minnesota and New York, you can't believe it. There was a few flurries and everybody went crazy. Anyway, so I hope you're having a good week. Now, we are approaching the last week, week 8, and this weekend is the weekend we really need to have the vast majority of the project completed. And as I said, let's share it in the Google Doc so I can talk to you and we can go in and work on it together. So a couple of things I want to go over tonight. First of all, make sure you fill out the evaluation for the instructor. I really appreciate that. I read those, Concordia reads those, and I'm always looking for ways that I can serve you better, and I would appreciate if you could do that. The other thing is you only have to complete this week the correlation and the regression assignment. Now, the problems that I gave you can be solved with SPSS pretty easily. SPSS is pretty good at correlation and regression, and they're two different things. I'll go over that in a minute. However, the calculator I sent you will work just as well too. I really like that calculator. And the thing you have to keep in mind is when you're starting to write your dissertation, you can keep your data wherever you want. You can keep it in a Google Sheet, and Google Sheets, which I use, has all kinds of statistical tools built right in. So you can have all of your data in the sheet. You can do t-tests, correlations, anything you want. It's an amazing world we're living in right now. So the last assignment for the week is internal and external validity. And these are two concepts that are important. Let me give you an example of what the difference is, and it's important to note it. So let's say we have a study, and we want to study whether eating jelly beans can increase the performance on a math test for third graders, okay? And we want to conduct an experiment. Of course we can't, because we can't give third graders jelly beans. Somebody wouldn't like that too much. But let's say we could. So let's say we want to see if this works for all third graders in Kentucky. All right, so we set up an experiment, and we do not randomize the control and the experimental group. So we don't know whether they're equal to begin with. Then as we conduct the experiment, it's not the jelly beans that are the only independent variable. There could be other variables that influence the results on the final exam for the students, because all appropriate controls were not put into place, and the experiment was not done well for several reasons, and you can read about what are called the threats to internal validity. So then we come to a conclusion that the jelly beans increase test scores for the third graders, and there's lots of problems with that. So those are called threats to internal validity, meaning we suggest that jelly beans are the cause, but they are likely not. So that's an experiment with poor controls. That's an experiment with lots of threats to internal validity. What we are suggesting is the cause is not for that group. The threat to external validity comes from the fact that even if we sampled third graders in Kentucky, maybe we only sampled third graders in urban Kentucky. And if we didn't randomly sample from the population, then even if we conducted a very good study with internal controls that had no threats to internal validity, meaning that we can identify the jelly beans as being the cause of the increased test scores, it doesn't work for all third graders in Kentucky. It only works for urban third graders in Kentucky. That's called a threat to external validity. the results don't apply to the population we intended it to apply. It applies to a subpopulation, even though the internal validity is very good. So that's important to note. That's the real difference, and I've sent some information on that, and that's part of your journal. So looking back and looking forward on the projects, the real key is to have a good one-question model. So a one-question, 3 hypotheses, or one question, 1 hypothesis, second question, second hypothesis, third question, third hypothesis model is pretty common. And you can ask as many hypotheses, you can formulate as many hypotheses as you want. You can test for differences in GPA, you can test for differences in anything you want to know about. That's the beauty of statistics, is you can set up a hypothesis that says, is the mean number of black holes in an elliptical galaxy is equal to the mean number of black holes in a spiral galaxy, if that's what you want to know. And then if you reject your null hypothesis because you've taken samples of galaxies, which they do things like this all the time, now we know something. We know that the shape of a galaxy has something to do with the number of black holes in it. So you can set up hypotheses in education to compare groups on any dependent variable you want. And so you've come a long way. I've appreciated it. And the last thing I want to leave you with is, I know the course has been challenging, and that's good. Everybody's done a good job. You want to take some of these principles and you want to keep them in your mind and keep thinking about good questions, good hypotheses, 2 independent sample and dependent samples t-tests, how all that works, so that when you get to the dissertation, it's not all gone. And if you have a good final project, that can almost roll into a dissertation. And if not, it will serve as your model for what you want to do. And so I certainly hope you think of it that way. So do a good job on that. The other thing is, some of the things that you've learned in the course, normal distribution and standard deviation, the more you know about data and how to analyze it, the better off you're going to be in education. Because in education, like every field, if we're using real information, then we make better ethical decisions. So if somebody comes up to you and says, well, small class sizes are the key to student success, well, that's very general. Now, if you ran a study and you found that it just isn't true, which I don't know, I haven't done a study like that, then we wouldn't want to be funneling resources that way. We might want to be using resources in another way. So I was talking to Craig about this the other day. The more data we have and the more we learn how to use it correctly, the better our decisions are in education and in life and in our policies. So I hope I hope you take kind of that into consideration. And so we're going to spend this weekend really working on these projects. Now, in the project, every section has to be filled out, and I want you to simulate what you would do if you were conducting this study. Exactly how did you sample? What sampling method did you use and why? Maybe you can't random sample. Then explain what you're going to do. What are your threats to internal and external validity? And then, most importantly, of course, write up your results correctly in APA formatted and put your data in an appendix and a survey in the appendix if you need a survey to operationalize a variable. So we're coming up on 10 minutes, and we got one more week to go. I'm here for you for any capacity that I can, and everyone have just a great day. Okay, thank you. Bye.